Okay, this review is going to look a little different because I'm going to walk you through the notes that I just sent on Remind 101. So they're all already done. I'm just going to explain what happened on each question. So you already have the answers here, and if you need to listen to any explanation, you can just fast forward to the question you want to look at, and I'll explain it to you. So in number 1, you're solving each equation by graphing. So it has to be equal to 0, so it is. So then I can find my a, my b, and my c. My a is in front of my x squared term, my b is in front of my x term, and my c is my independent term or my constant. Direction of opening is up because my a term is positive, so it's a happy parabola. Our axis of symmetry is always going to be an x equals something line because it is a vertical line. So I get x equals the opposite of b, or negative b, whatever you want to say. B is negative, so that's going to make it positive, over 2a. So when I reduce this or simplify this, it becomes 4. I plug that x value back into the original equation, like I did right here, to find my y value, because your vertex is a coordinate. It's always a coordinate. So you get an, you get an x, y coordinate here. So x, let's get that a color that I can see. Here we go, x, comma, y. So we have our x value. It shoots into that x spot, but then we have to find our y value, which we get when we plug it back into the original equation. The vertex is going to be a minimum because it opens up, so it's at the bottom of the parabola. Our base graph, remember, our base graph will always be y equals ax squared. So it's this term right here. So I always use -2, -1, 1, and 2 because I want 2 to the left, 1 to the left, 1 to the right, 2 to the right. And then it's just going to take that 4, 1, 1, 4 pattern and multiply it by 2. You can definitely plug it back in to get these, but you should not be getting any kind of negative numbers here because it opens up. Remember, so our y value should not be negative. When I graph this, I graph my vertex first, so I go to 4, -2. When I go to 4, -2, I get, put my dot there, and then my axis of symmetry runs right through it. Notice it's a vertical line, goes all the way past to the end of my graph. Then I go left 1 up 2, left 2 up 8, right 1 up 2, and right 2 up 8. Remember, these should be the equidistant for my axis of symmetry. So this is 2 away, this is 2 away, this is 1 away, this is 1 away. That's why you could fold this parabola on top of itself over that axis of symmetry. Remember, the axis of symmetry is halfway in between my x value points or my roots or anything like that. And then the roots or solutions, which is asked for here, is where it crosses the x-axis. So I just count from the origin. So this is 1, 2, 3, and this is 5. So 3 and 5 would be my roots or solutions to number 1. Number 2, same thing. We're going to start, make sure that it's equal to 0. It is equal to 0, okay? My a is -1. My b is what's ever in front of the x term. I do not see an x term, so it is 0. -3 is my constant, so that is C. Direction of opening is down because -1 is negative, or -1 is negative. A is negative, so it tells me it opens down. Axis of symmetry, it's -b over 2a. Well, 0 over anything is 0. Plug 0 into here, 0 squared, right? And I'll show you again here in case, since I didn't put it here. So I'm just plugging in 0 into the equation. Well, 0 squared is 0, -3 is -3. So there's our vertex. It's a max point because it's opening down. And then the base graph is y equals -x squared because that's the ax squared here. And so what does that do to our 4, 1, 1, 4 pattern? It's going to make them all negative. So when I graph my vertex first, 0, -3. My axis of symmetry is kind of hard to see on here. Maybe I'll make it yellow so you can see it. But there's your axis of symmetry. It comes right through here. Remember, it's a vertical line. It's never going to be a horizontal line. Axis of symmetry. Okay? So there's our axis of symmetry. This should be perfectly symmetrical around that axis of symmetry. And the reason, so I go left 2, down 4, left 1, down 1, right 1, down 1, right 2, down 4. And then I connect my dots, make a smooth line. This one will have no solutions or roots because it does not cross the axis, the x-axis. So this is a no solutions answer. That's what it looks like. Number 3, first thing you must do is make it equal to 0, so you add 9 to both sides. So now I have my A, my B, and my C. A is 1, B is -6, C is -9. It opens up because A is positive. Axis of symmetry, X equals negative, or the opposite of B. So I'm going to get a positive 6 over 2 times A, which is 2 times 1. So in this case, we get 3. Plug in 3 to the original equation right here. So I get 3 squared minus 6 times 3 plus 9. Well, that's 9 minus 18 plus 9, so I'm going to get 0. This is a minimum point because it is opening up. My base graph is y equals x squared, -2, -1, 1, and 2, because I want to go 2 to the left, 1 to the left, 1 to the right, 2 to the right. 4, 1, 1, 4 is what we always get when we have this base graph. So I graph my vertex, then I did my axis of symmetry. It goes straight through that vertex. Go left 2 up 4, left 1 up 1, right 1 up 1, right 2 up 4. Again, these should be equidistant from the axis of symmetry here. And then it is only touching the x-axis in one spot here, so we get x equals 3. So there's one solution, and we also call that a double root. Okay, number 4. 4 through 13, actually. These were all solving the quadratic equation by factoring. Make sure, always, 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 that it is set equal to 0 before you start this process. Because if it is not, you cannot factor correctly. So number 1, I had to subtract 12x from both sides. So I get 3x squared minus 12x equals 0. This is not a trinomial. You should always be looking for a GCF first. I pull out a 3x. I'm left with x minus 4. So then I set each of these factors, and you can think of this one in its own thing too. So this is a factor, so 3x equals 0 and x minus 4 equals 0. Well, this obviously, x has to be 0. 0 divided by 3 will be 0. And I'm going to add 4 to both sides, so I get x equals 4. I'm going to move through these pretty quickly. First thing I do is subtract 66 from both sides, so now I have a trinomial. Once you do this, this is an easy one, leading coefficient of 1. I put my 2 binomials down. I look for factors of 66 that have a difference of 5. That would be 6 and 11. I need more negatives here. So 11 will be negative, 6 will be positive. What will make this 0? Well, if x is 11, this will become 0. And what will make this binomial 0? -6. So -6 and 6 would be 0. Again, you can set them equal to 0, subtract 6 from both sides, and you'll still get the same answer. Number 6, when I subtract 121, I get a difference of squares. We must not forget these things. So this is a difference of squares. And with that, we get x minus 11, x plus 11, so my two answers are -11 and 11. That's what will make both of those 0. This one I'm going to slide over, so I'm looking for factors of -100 that add to or have a difference of 21. That would be 25 and 4. Then when I divide out that 10 again, I'm going to simplify my fractions. By simplifying my fractions and not doing any more, I can already see my answers, can I, from right here? So if this is positive 5/2, then this needs to be -5/2 for x. This is -2/5. This has to be positive 2/5 because that is what will make it 0. So I'm just going to stop there. You could definitely swing back and do your whole solving, 2x plus 5 equals 0 and 5x minus 2, but you will get the same answers here. 8, same thing. Swing that 3 over. We're looking for factors of 42 that have a difference or that add to 13. That would be 6 and 7, and they both have to be negative because they multiply to a positive, add to a negative. Divide that 3 back out and simplify. When I do that, this becomes 2. So x minus 2 will be this one. And this will still be x minus 7/3 because I just want to leave it as a fraction because I'm finding the solution to that. I don't need to find the factor. Number 9, this is again a pretty simple one. Have to multiply to 25, add to 10, so that's x plus 5 and x plus 5. This is what we would consider a double root because it's -5 twice, so that means it's sitting on that x-axis at -5. Number 10, same thing, we're going to slide this 16 over, so I'm looking for factors of 16 that will add to -8. Well, that would be -4 and -4. So when you have -4 here and then divide out that 16, you eventually get x minus 1/4 and x minus 1/4. So again, this is a double root, and this is the answer to that is just 1/4. Number 11, When we do this one, this is a difference of squares, so this is 3x and 3x for your first term, 8 and 8 for your second. One's positive, one's negative because your middle terms drop out. That's why there's no x term. So this will be another way to write this is a plus and minus 8/3 because this would be 8 divided by 3, positive 8 divided by 3, and negative 8 divided by 3. Number 12, you're going to add 27 to both sides. And you're looking for factors of 27 that add to 12. That's 9 and 3. So your answers are negative 9 and negative 3. That one's pretty straightforward. Number 13, look for the GCF. Pull out an x. So you're left with x plus 10. And so x equals 0. If it's out here by itself, you could just set that equal to 0. Remember, x equals 0. And then x plus 10 equals 0, so x has to be negative 10. So that's your factoring. This goes back to Chapter 8. So if you weren't good at Chapter 8, this is going to impact you on Chapter 9. That's why we always say you must keep up with all of your skills. Okay, last one was about the discriminant and the quadratic formula. Discriminant, right here, you do not have to memorize this. It is on your formula sheet. It is b squared minus 4ac, and it helps us understand whether we're going to get 2 answers, 1 answer, or no answer, whether I even have to finish the quadratic formula. So the first one, we have to set it equal to 0 first. Then I have a is 3, b is 2, and c is negative 6. Then I plug it into my formula, so I get b squared minus 4 times a times c. I got 76 here. Well, the square root of 76, that'll be positive, so I'm going to get 2 roots. That's all it's asking you for here, right now. Number 15, same thing. It's already equal to 0, though, so I have 1, negative 5, and 9. I plug this into my formula. I get negative 11. Can't take the square root of negative 11, so it's going to be no solutions. The last one, again, already equal to 0. 4, negative 12, and 9. You plug that into your formula, b squared minus 4ac. Please note that if it's a negative number, it is inside the parentheses when you square it or when you multiply everything else, okay? It has to be in here because a negative 12 times a negative 12 will give me a positive 12. It gives me that positive 144, which is what I need. And then minus 144 is 0. So 0 tells us that there's going to be one solution. Here is your quadratic formula. It is x equals negative b plus or minus the square root of our discriminant, b squared minus 4ac, the whole thing over 2a. Again, you do not have to memorize that at all. It will be on the board. It will also be on the sheet. So we do the discriminant first to see whether we even need to go on. This gives me a positive number, so that lets me know that there's going to be 2 roots here. After I did the discriminant and we made sure that it was equal to 0. Then it's x equals the opposite of b, or negative b, and b was negative 8, so I have to put that inside the parentheses, plus or minus the square root of 144 all over 2 times a. And so when I reduce that or simplify that, it becomes x 8 plus or minus 12 over 2, so 8 plus 12 over 2 will give me 10. 8 minus 2 over 2 will give me negative 2. So there's your 2 roots there. And again, if you wanted to check, plug it back into the original equation. If they both give you true statements, then you know you have the correct answers. 18, same thing. We need to make it equal to 0. A is 2, B is 5, C is negative 8. When I plug it into the discriminant, I get 89, so I know I'm going to get 2 roots. X equals the opposite of B, or negative B. So negative 5 plus or minus the square root of 89. I've already done the discriminant, so I can just put that number right underneath the square root, and then all over 2 times 2. When I plug this straight into my calculator, I should do negative 5 plus the square root of 89 all over 2 divided by 2 times 2, which gives me 1.1, and then negative 5 minus the square root of 89 all over 2 times 2, which will give me negative 3.6. Use your calculator to convert this. You can do this first and then add the negative 5 and then divide by 4. But you can put this exactly in, just do the plus one time and then do the minus one time. All right, last ones. So if I look at 19, same thing. It's already equal to 0 for me. So A equals 3, B equals 8, C equals negative 1. When I plug it into the discriminant, we get 76. That's a positive number. So that means we should get 2 answers. So we get negative B plus or minus the square root of 76 all over 2 times A. When we plug this into our calculator, we should get 0.1 and negative 2.8. If you are not getting these answers from your calculator, for one thing, use your fraction bar and and do that. You do the alpha y equals. If you don't have the opportunity to do that, you're going to put the top in parentheses, then divide by whatever's in the bottom. Okay, that way it'll make sure to keep this all together and then divide this. Otherwise, it's just dividing the last term by this. Number 20, when we plug this one into the discriminant, we get a negative number, so that's a no solution. And 21, A is 25, B is 30, C is 9. I believe we did this in both classes. So you get the discriminant of 0, which means you're going to get one root. And when you reduce this one, you get negative 30 plus or minus the square root of 0 all over 2 times 25. So you'll get negative 30 over 50, or negative 3/5, or negative 0.6. You must be able to know all of those because you never know how it's going to look in multiple choice. If you're doing it by hand, we'll accept either of those answers. And then this one, you must make it equal to 0. Same thing up here. So A was 10, B was negative 17, and C was 6. C should have been negative 6. Now that I'm looking at that, see, I even make mistakes when I go through here. So I get C equals negative 6 and negative 6 here. So we get 17 squared times, or 17 squared plus 240. Is that right? Whatever that is. So instead of the square root of 49, this should be whatever 17 squared is, and I do not have a calculator right now. 17 squared plus 240, whatever that is, under here, and that will give you your two answers. So I will give you corrected answers. Give me a moment. Okay, so I fixed the calculations. This should have been what you did. X equals 17 plus the square root of 529 over 20, and 17 minus the square root of 529 over 20, and these are the two answers you should have gotten, 2 and 0.3, or 3/10. Okay, so those are all of your answers. You should be ready. If you need more help, go to the online book. You can do Khan Academy. You can YouTube other videos about finding solutions and roots of quadratic equations. But you should be ready. I will be at school by 6:10 tomorrow morning, so if you need to ask any questions, feel free to do that then.